So this one is question 5 from alternative to practical light experiments. A student is finding the focal length of a lens, like finding a point where all the parallel light rays converge. And figure 3.1 shows an apparatus illuminated object is there, the lens is placed on the screen. Now, looking at these distance, we can identify without calculation, we can identify that the image size will be bigger or larger than the object. Why? Because this distance decides the size. If object distance is shorter and the image distance is longer, it means that the size of image will be larger. And if it was the other way around, like the distance between the lens, if the distance between the lens and the object is greater than the distance between the lens and the screen, like lens was example placed here. So object distance is more than the image distance. In that case, the image size will be smaller. And if they're equal, then they will have equal size. So a student places a screen, as you can see, 70 centimeter from the illuminated object. So this total distance from illuminated object to the screen, that is equals to 70. He places the lens close to the screen and moves the lens slowly away from the screen until he observes a clearly focused image on the screen. Then he measures a distance u, that is the distance between the lens and illuminated object, and he measures v, that is the distance between the lens and the screen. Then he repeats the procedure using different distances between the screen and the illuminated object, like 75, 80, 85, and 90. The readings are shown in figure 3.1. So you can see the readings are there. We have to calculate and record. So we have to calculate and record these values. In the table 3.1, UV for each value of a D. UV means U multiplied by V. So if I do U multiplied by V, like 22 times 48.4, what's the answer?
1064.8.
1064.8. So we will round off to the nearest whole number. So 1065. So for this one, we'll write that this value is 1065. If 20.7 times 54.5, what's the answer? 1100 and it is, can you check again?
It's 1128.15.
So we have 28.15, so we can write as 1. So we can write 1128, this value. Then 20 times 60.
1200.
Yeah, so we don't have to round up. 19.5 times 65 per day.
1283.1.
1283. Then 19 times 71.2.
1352.8.
Okay. So these are the values for u into v, like for a value of a d, because next page we have to plot a graph like value of d is 70, 75, 80, 85, and 90. And the u into v was 1065, 1128, 1200, 1283, and 1100, 1353.
1353.
Yeah, 1353. So these are the values for u and v. Now we have to plot the results for the next page. As you can see, and they mention here we have to plot a graph for u and v, like u multiply by v, and u should be there on the y-axis. So on the y-axis, we should have u. On x-axis, we will have v. And you do not need to start from origin. Like we don't have to mark the origin. So on y-axis, it is u into v. And what is the maximum value of u into v? The maximum value is 1353. And what is the minimum value? It's 1065. So if I start like 1000, then 1100, 1200, 1300, 1400. So I can have this. So as I mentioned, we don't have to start from origin. So you can start with any number. So example, the first value, you say it is 1000. The second value is 1100 after 10 boxes. So each box is equals to 10. Then 1200, then 1300, then 1400. And always label the axis. So what we are plotting on y-axis u into v. So we'll write u into v. And what is the unit? Unit is centimeter square. Then for D, the minimum value is 70 and the maximum is 90. So it means we don't, again, they mentioned we don't have to start from origin. So we can start with any number. So example, if we start with 70, then this is 80, 90, or if we start with this, this is example I took as 70, then here took it at 80, and this is 90. So here what we have, like this will be 72.5. Even like if you can do other way around, like, but we don't have to start from origin. Like we don't have to start from 0 comma 0. So we can take any value. So if I took this as 70, this will be 80, this will be 90. But usually whenever you plot a graph, like if I select this as my scale, what is the drawback here? That I should use more than 70% of the axis. If I'm using this as my scale, it means only what I'm using 50% of the x-axis. So that is not the right scale. So the right scale is the one which in which you are using the one in which you are using the like 70% of the axis. So we have to use a 70% of axis. That's why when I select the first, the reason why I just reselect the axis so that to explain idea that what is a suitable axis when you mark. So this will be 75 and this will be 85. Now we have the values when D is equals to, so we have to mark the points when D is 70, 1065. So this was 1000, D 70, 1065. So 1010, 20, 30, 40, 50, 60. And then between 60 and 70. So this will be 1065. Then 75 and 1128. So 1110, 120. So 38 some or 28 somewhat here. Then at 80, it is 1200. So this will be the point. At 85, it is 1283. So 1283. And then 1000. At 90, it is 1301. 1353. So 5 boxes, 1, 2, 3, 4, 5. So it will be here. So these are the points. Then what we have to do, we have to draw a line of a best fit whenever a question is there. So we'll draw a line of a best fit joining all the points. So what is the line of a best fit? The line which is having equal number of points and above and below. That's the line. Like as you can see, first, and it's not necessary that the first point should be below and the last is up. It can be anywhere, but in this one, the first is up and the last one is below. So this is a line of a best fit. Then the next one, we have to find the gradient. How to work out a gradient? Whenever you're finding the gradient, you should take 2 points, but not the same point which you use for plotting. It should be other than those 2 points. So you can take any of them. Example, I select, and the distance between the 2 points which you are taking, that should be about 5 centimeter for the accurate value of the gradient. But don't select the same points which you already use for the plotting. Don't use them again. Like I select this as my first point, and I selected this as a second point. So what is the formula for gradient? You have to learn this formula, that gradient is y2 minus y1 over x2 minus x1. What is y1? When you plot a graph, like when you mark the position, that this is y1, first point on y-axis y1, and the second point on y-axis is y2. And same way, the first point on x-axis is x1, and the second point on x-axis is x2. So what is y1 here? It is just one box below, so it is 1090. So the value of y1 is 1090. Value of y2 is how much? It's 3 boxes above, so 1330. X1, the first point on x-axis, that is 72.5 because it is between 70 and 75. So x1 will be 72.5. And what about x2? That will be 82.5, 87.5. Then we use the formula that gradient is y2 minus y1. So 1330 minus 1090 divided by 87.5 minus 72.5. Whenever such question is there, solve the numerator separately and denominator separate. So if 1330 minus 1090, what's the answer for that? First, the numerator.
240.
So the numerator is 240. And what about denominator? 87.5 minus 72.5.
15.
15. So 240 divided by 15. What's the answer?
Uh, 16.
16.
So it means the value of the gradient is equal to 16. And when you're finding the gradient, you have to show all this on your graph. Like you have to represent like the position of a y1 and y2. These lines which I draw here for y1 and y2, you have to show these lines on the graph. So the value of the gradient is equals to 16. So gradient is equals to 16. The next one, they are saying the focal length is numerically equal to gradient. So value of the focal length and gradient are equal. So if the gradient was 16, what will the focal length? That will also be 16. But because it should have a unit, so what is the unit of a length is SI unit is meter, but focal lengths or object distance and image distance are usually in centimeter. So this will be in centimeter. Then suggest a practical difficulty when you are carrying out this experiment. Like state 2 difficulties when we are carrying out this lens experiment. What are the practical difficulties? Difficult to measure or find the center of the lens. Like measure the length as we are doing here. It's not having a perfect like the center is not marked on the lens, and you have to measure all the distance from center of the lens. So difficult to identify the center of the lens and measure the distance. That is one of the difficulty. Second thing, maybe what might happen, that this experiment is not done in a dark room. It should be dark in a dark room, but if there is another nearby, any other source is there, so the image won't be clear on the screen, because already you have too much light in the room, so you won't be able to see the image on the screen. That is the second reason why you may not have an accurate result or answer for this. So finding the exact position that gives the clear image, that is one thing. Room may be too bright is there, or measuring a distance, or difficult to measure distance from center of lens to object and screen. This is one of the difficulty. Maybe the room is bright, or third one is there difficult to get the exact, like, a sharp image on the screen. This all, it does not give a very sharp image. That's also another difficulty.